memorize the formula for surface area and volume of a what is this, cylinder. Okay. Like if I had a box, the surface area of the box is just the size of the box. You just add up all the rectangles, right? Okay. But in a cylinder, the formula is a little different because, like, if here's my cylinder cup, if I would cut it and lay it flat, the sides now become a rectangle. And the length of that rectangle is the perimeter of the base, because when I would lay it flat, okay, it would be the length of that rectangle. The height of that rectangle is the height of my cylinder. So I just want to explain where the surface area formula comes from. The surface area formula for a can, and we're not going to use the example above, so you can use that space if you want. Comes from 2 pi r, that's the formula for circumference, times height, so this is the area of that rectangle. But then also in the can you have the top and the bottom of the can. What are the shapes of the top and bottom? Circles, and so what you end up adding on is 2 base areas, or 2 pi r squared. I'm only showing you where that formula comes from so it makes sense that it's not just a bunch of numbers. Another thing we're going to use in this problem is I give you the volume. And so just a reminder, the formula for volume of a cylinder is pi r squared times h. Okay. So jot those things down. So basically in this section, we have to rewrite things in terms of other things. How did we do that in the last problem? What did we rewrite? Didn't we rewrite the length of the rectangle in terms of the area divided by the width? Okay. In this problem, I'm asking you to find a radius and height. And if I ask you to find radius and height, I'm asking you to find 2 things that we don't know, right? And so in order to do that, I'm going to have to use some other information to rewrite one variable in terms of the other, just like I did before. The information I'm going to use is this. 2 liters is a measurement of what? Volume. I know what the volume is. So I am going to take the volume equation and I'm going to put 2 liters in for the volume, except I need to measure my centimeters, or my radius and height in centimeters, so instead I'm going to use this. 2 liters is how many cubic centimeters? 2,000, right? So here we go. 2,000 equals, I just took out V and replaced it with the volume, pi r squared times h. We're going to get h alone. So what should I do? Nope, this is the volume formula. So how would I rewrite this with h alone? What do I do to both sides? Yep. Alright. So what's the point of doing this? This is my rewriting part. Now I have h equals this. So now when I do my surface area equation, which is the one I really want to find, I want to find when the surface area is 1,000. Now I'm going to be able to swap out that h and replace it with this. And so then I won't have 2 variables anymore. Okay? So let's first rewrite the surface area equation. And then you can see what I'm doing. I'm then going to plug in things that I know. I want to know when the surface area is 1,000. So what should I put in the spot there? Instead of surface area, I write 1,000. Also, Somebody Jolly Rancher that. Sorry. I rewrote the formula incorrectly. Alright. I'm also going to replace h in the problem with what I found h to be over here. So I have 2 times pi times r, and in the place of h, I'm going to put 2,000 over pi r squared. So that's this part. Okay, so what's the point of me doing that? Up here I couldn't solve it because it had an r and an h that I didn't know. Now, what do I have as my variable? Only an r. So we're going to just solve for r. And again, we can use our graphing calculator to do that, but let's at least simplify a little bit. Do you see when I multiply these two things together, something cancels? A couple things cancel, huh? Can somebody tell me one thing that cancels? Pi. What else? An r, right? So one r cancels here and one cancels there. So now we are left with the equation 1,000 equals 2 times 2,000 over r. That's 4,000 over r plus 2 pi r squared. So what we're going to do is we're going to plug this into our calculator and solve. I am going to put 1,000 in for y1 and this expression in for y2, except of course we don't have an r, so it's going to be x. Okay. Okay, so wait till you're with me here. When I'm picking a window for this, I need to see a little bit above 1,000, okay? So when I go to window, that's too big. Let's maybe make Y max 1,500. And I'm guessing because I'm finding a radius of a can. I'm going to guess it's not 100 centimeters. Think of a can. But I'll make it a little bit smaller. Let's just try 50. There's my line. Aha! There are two answers. One's going to be a skinny, taller can, and the other is going to be a shorter but wider can. All right. Let's see. Who's got it on their calculator? Over here, this half the room. Would you find the one to the right for me? Okay. And over here, find the one to the left for me. Sadie, did you get R was approximately 9.7 centimeters?
Yeah.
Okay. Preston, what did you get over here? 4.6-ish? Okay. So there's two answers. Can somebody tell me how do I find the height that goes with them? Yeah, let's just plug it back in over here. Okay? So I'm going to do 2,000 divided by pi r squared, all in parentheses. So 2,000 divided by, I know, Thank you, Bo. Pi times 9.7 squared. So the height of this can is about 6.8 centimeters. So it's wider than it is tall. Does that make sense? This would be a really short but wide can. And then let's do this one. This one is very tall.